This e-tutorial will explain how you can get a sheet metal object that can be unbent and rebent starting from a model obtained with standard solid features. And so how you can create rips and close corners on it. First of all, let's load model file 2_rips.e3. Let's now expand the history tree in order to better understand the model structure. The object has actually been thoroughly created using standard solid features. So let's roll back to the base profile and then forward again using roll forward. First, there was the extrusion of a 2D profile through the linear sweep command. Then a linear slot was added, and eventually the shell command was used to add the proper thickness. Let's now complete our roll forward, and then let's open for our convenience the named views dialog box. Then we shall set the view to right front. Let's start by launching command sketched rip. In the rip by drop-down list, let us choose 2 points, since we need to create a rip in the position identified by the 2 points we are going to select on top of the plane face at the sharp edge. And then let us select also the top face, and let's apply using apply on top of the selection list. Let us now repeat the very same operation on the top plane face at each of the remaining 2 sharp edges of the solid. At the third, let's click OK on top of the selection list rather than apply. Let's now go on creating rips. So let us properly rotate the model and zoom a sharp edge on which we want to create the rip. Here is the sharp edge and here is our zoom. So let's start the edge rip command. The rip on the edge can be symmetric, which means it is created symmetrically with respect to the line connecting the inner edge to the outer edge on both parts. Let's apply and we'll obtain a symmetric rip so as to leave a 0.5 mm gap between the 2 faces, according to what is specified in the global sheet metal properties. Let's now redefine the rip by right-clicking on the corresponding icon in the history tree and choosing Redefine Feature in the context menu. As you can see, the value of the gap under local properties is of 0.5 mm. Now we can create a center rip by setting the type to middle. In this case, the 2 adjacent parts are cut along one of the 2 possible common faces. You can choose which one by double-clicking on the arrow identifying the cut direction, and the rip will be aligned to the median axis of the selected common faces. We have properly zoomed the region in order to let you appreciate the effect on the result. Just to summarize, in order to determine which of the 2 parts will have to overlap the other one, by double-clicking on the arrow which has shown up, you can establish that half of the first must overlap the other one. Now, let us redefine the feature again, and let's create a rip with the type set to full. In such a case, the 2 adjacent parts are cut along one of the 2 common faces. We are now setting the view properly. Also, in this case, you can choose which one by double-clicking on the arrow, identifying the cut direction. And the rip is aligned along the edge identified by the selected direction. In our specific case, we shall invert the cut direction by double-clicking the arrow, and will eventually obtain the identified part will fully overlap with the other one. Now, by setting the type to symmetric, we shall really actually create a rip on each of the 3 sharp edges. As you can see, we properly rotate the model and we create the symmetric rip. In our model, though, we also have a curvilinear part, and then we need to create a rip on it at selected positions. Let us start the edge rip command again, and let us select the 3 following edges, always keeping the type to symmetric. Then let us confirm. As you can see, we have removed material in order to create a rip on our solid. Now let us set the view to right back. Now let us rotate the model so that we can operate as we need. And let us set the work plane onto this face, since we need to create a profile which will be used to create a rip afterwards. In the meantime, let's set the view back to top so as to more easily create our profile. Let's activate the 2D profile sketching environment and let us create a simple 2 points line this way. So first we snap to the workplane origin, and then we indicate the coordinates of the second point through the enable point coordinates command, and the coordinates will be these ones, 0, -60 and 0. And then we confirm by clicking OK, and then we exit the command and return to the 3D environment where you can see the created profile that we shall use from now on. Let us start the sketched rip command. Well, as you can see, since the profile is already selected, the rip drop-down list has been set automatically to profile, and the face has been automatically selected since the profile lies on it. Under more options, the propagate to adjacent faces checkbox is not checked. In this case, a rip is created only on one of the 2 faces, while we need the rip to be created also on the other face. So we shall now redefine our feature and check the propagate to adjacent faces checkbox and rebuild. Now, as you can see, we have the desired rip. Another method to create rips is the one which uses the face rip command. In this case, the rips are created by removing faces of the solid. Let's start our face rip command and let us remove only some parts of the object. We have first set the view to right back, and here are the faces to be removed. Now let us take a closer look at the Vertex Rip command. Once a point has been selected, the system identifies all the adjacent edges in that very point. Therefore, it is necessary to indicate which part is to include the bend. So let's keep the radius value to 1 for this group 2, rip by radius. Since we are going to have a bend here, while on group 1, to switch to group 1, you can click on the left arrow button close to the information edge, we're going to have a gap, which can be obtained by setting rip by to gap, according to the fact that since on group 2 will have a band, it will be necessary to create the rip here. So now let's go on creating the rip using edge rip. We'll keep the gap of 0.5 millimeters. We'll select the 2 edges, the linear and the curvilinear one. with the type set to symmetric, and confirm. Let us now zoom to see the rip that we have obtained. We must now verify whether our object can be unbent or not. Therefore, let's start command unbent, and let's select the face to be kept fixed, and here we have our object unbent. Let us see it in an optimized view, and here it is, perfectly unbent. Now let's try to rebend it using command rebend, and let us select the face to be kept fixed, and then let's confirm. Here is our object properly rebent. Now we shall see it optimized. Here we have our object perfectly rebent. We have now rebent the object to show that you can modify local properties here. For example, you can change the type from circular to rectangular. As you can see, we have the corners here are circular. Now let's rebuild and select the Edit Properties command. In the corner relief tab, we set the corner reliefs to rectangular, and here we have them. So now let's edit again the properties and set them back to circular. By confirming, we get again our circular reliefs, and we can rebend it and confirm, and still we have our object properly rebent. Let us see it as a whole in a view, in an optimized view. After bending the solid, there can still be positions where you think, for instance, too much material has been removed. In such cases, we've got to close these corners. Let's start command close corner. Let us select the following face, setting the type to full. Here it is. And we'll set the type to full. Let us repeat the same procedure, attach rip on the other linear parts. Since we have chosen the wrong part, let's redefine our command and double click on the arrows to select the correct one, and then we apply. Now let us properly rotate our model to see the other corners. Here we can show you how some step actions about rotating the view. Now we shall get our final view really as we like it, with complete control on it. So let's go on closing corners through the close corner command. We'll select the faces, and go on again, changing properly the view in order to facilitate selection. Here we have another one. So close corner, select the faces, and the gap will be adjusted. So I mean just one face will be extended, and here we are. Now let us rotate again our model to take a look at this corner here and redefine it, because we did something that was not correct. So let's change the direction, keeping the type to full. and here we are. Since the close corner command does not apply to curvilinear corner, how can we create curvilinear closures on our model? The answer is in using the interactive modeling commands available in ThinkDesign. Let us start modifying interactive modeling move faces. Therefore, let us select the top curvilinear face. Let's move it along Z of a value of 1.354 till it matches the point identifying the height of the adjacent linear parts. Let's now confirm. So on this side we have properly raised the face and consequently obtained the closure. Below, on the contrary, we'll have to extend the curvilinear part towards the external side. We shall still use the interactive modeling, namely the offset faces command. We shall assign an appropriate offset value of 1.35, and with such value we shall obtain the closure. Then, using the interactive modeling features, we have managed to extend the faces so as to obtain the desired closure. Therefore, just like we managed to make an object originally created with standard solid features, unbendable and rebendable. As you can see here, we have unbent it.